All right, we are back at it again. We have made it to Module 6. So Module 6 is all about transmissions and final drives. Transmissions hold a really special place in my heart because I rebuilt transmissions for a few years, and they're pretty cool. They're pretty amazing how they work. So now some of you guys aren't going to necessarily rebuild transmissions or have anything to do with the rebuilding of transmissions, but it's important you know how they work and just the basics, the understanding of how they work, because we're going to shape you into an all-around best technician possible. So what we're going to talk about today in this module, transmission types and how they work. We're going to show you some of the transmission components. We're going to talk about manual transmissions, transfer cases, and final drives. So here we go. This is the transmission. Transmission's job is to change the speed of the vehicle while keeping the engine RPMs in a useful power band. So think about that. You go down the road, your engine without a transmission, your engine will be up to 6,000 RPMs and your car might only be doing 30 miles an hour. So by changing the speed of the vehicle while keeping the engine's RPMs in a useful power band. Most of today's transmissions, all of today's transmissions actually, are electronically controlled and hydraulically operated. So we're going to show you what that means, but inside this transmission, everything happens using hydraulic force and hydraulic pressure. Some of the earlier transmissions that we're really not going to talk about because I don't want to waste your guys' time are controlled. There's no wires going to it, you know, I'd say 96 and before, they're all mechanically operated. So transmissions use what's called a TV cable or a throttle valve cable, also vacuum modulators, and the transmission used that to determine what the throttle position and the engine load were, and then it also used a governor or just a spinning contraption inside there that would tell the transmission how fast it was going. So it's come a long way since then, and again, we're really not even going to go over that because likely you guys will never have to deal with that. So let's start talking about the torque converter. If you back up one slide, okay, the torque converter, get my laser here, right there. The torque converter sits in the front of the transmission. That connects to the flywheel or the flex plate of the transmission. Okay, so what is a torque converter and what does it do? A torque converter really has two main jobs. Number one job is to allow the engine to rotate independently from the transmission's input shaft. It allows for slip RPM. So think about that. When you're at a stoplight, your engine's obviously still running, it doesn't shut off, but your transmission, if you could see your input shaft of the transmission, which the input shaft is what sticks into this hole right here, it is stationary, it is not moving. So how does that work? It's because of the torque converter. The torque converter allows for some slip RPM. So it allows the engine to stay running while the transmission comes to a stop. But it also has another function inside of it. It applies a clutch to lock the converter and eliminate the slip. And this is called a TCC or torque converter clutch. And next time you're driving your vehicle, I want you to really pay attention. Say you have a standard 4-speed automatic transmission. Feel the shifts. You're going to feel 1, 2, 3, 4, and then really pay attention because it's almost going to feel like a 5th shift as takes place if you're really paying attention. What that is the torque converter clutch locking up. Now a couple things about that. The transmission has to be up to temp before this happens, and there can't be typically any codes in the system. Why do we have a clutch inside that torque converter? So when the torque converter clutch applies, it's a 1-to-1 ratio. There is absolutely no more slip inside that torque converter. And the reason they do that is, number one, it increases fuel economy because now we're not wasting engine RPM it's going directly from the engine directly into the trans. Number two is it keeps the transmission running cooler, because whenever that torque converter is slipping, it's really generating heat. So torque converter clutch is applied in a high gear during a cruising speed. So TCC, if we're talking about 4-speed transmissions right now, will apply in 4th gear up to speed. On some transmissions, it also applies in 3rd gear. But its purpose, we talked about that, is to improve gas mileage and keep the transmission running cooler. Stall speed, you may have heard somebody referenced stall speed before. Well, what that refers to is the amount of RPM that the converter will spin before forcing the input shaft to spin. So another thing you can try when next time you're in your vehicle, step on the brake and step on the throttle. And there's only so much RPM you're going to get out of that thing. So if you're on the brakes and even if you floor the throttle, don't do it for a long time, or you put it to the floor for a couple seconds, you'll see your engine RPMs maybe go up to 1500 RPMs, and it's not going to go any higher. That's your torque converter that's your torque converter stall speed. So in racing applications, high performance applications, a high stall converter, you've probably heard of that, means a higher stall rate. So say you got a race car, you did the same stall test, you got your foot on the brake, your foot on the gas, you might get 2000 RPMs out of that. It's just allowing the engine to rev up a little bit higher, and that's kind of everybody thinks they want a high stall converter in their vehicle that they drive day to day. And I always try to talk people out of it, because it is so annoying when you have a high stall converter for a vehicle you're just driving around on the road. It creates a lot of heat that's not necessary, and it's actually pretty annoying to drive that way. We just mentioned that torque converter will allow the engine to rotate while keeping the input shaft stationary. Okay. So I got a video to kind of give you another little example of how the torque converter works. Okay, so watch this video. It's going to kind of explain to you what happens inside a torque converter and how it works. So you can see that first fan is spinning. It's actually forcing the other fan to spin. Same thing happens inside a torque converter. You have two turbines that spin right next to each other. The difference is there's fluid in between the two. So you can see the first fan spinning, even though it's not touching the second fan, it's causing it to spin. There you can see now we have the fluid in there. You can kind of see how it works. So the two rotating pieces in there never actually touch each other. They use the fluid friction to turn itself. So I think that's pretty cool. I remember when I first got started in the automotive industry, for a long time I was always curious, how does that work? How does this torque converter work? I even remembered the day when somebody explained it to me, and I actually kind of figured it out. It's like, oh, that makes sense, because I was thinking to myself, how does this work? So that's pretty amazing how that works, I think. Now that squiggly line is showing you how it can smooth out vibrations. So when your torque converter is not in lockup, it's going to actually smooth out some engine vibrations, some road vibrations, which is another reason why when you're in TCC lockup, torque converter clutch lockup, that's typically when we experience engine misfires, or when we can actually feel the engine misfires. Okay, so we're going to move on now. We're going to talk about the different transmission types. So these transmissions, there's obviously a big difference there. Right here is going to be a rear wheel drive transmission. Right here is going to be a front wheel drive transmission. And the front wheel drive transmission is also referred to as a transaxle because it actually sits sideways in the vehicle. An axle shaft is going to come out of this side, and if you can't see it, there's a hole on this side where another axle shaft is going to come out of. So this is actually going to be the front of the transmission, whereas of course this one on a rear wheel drive, this is the front of the transmission, and you have a drive shaft or a transfer case attached to the rear, putting power to the rear. So that's the two types of transmissions you'll see. Now let's take a look inside a transmission. Oh, there's a lot of parts in there, a lot of moving parts. But I'm going to give you an idea. I just want you guys to have a quick idea of what's happening and what makes these things tick. So we'll start out by showing you the pump. Right here is the pump. That's the hydraulic pump. You can see, hard to see, but there's a rotor and some vanes right there. Those spin, creating hydraulic pressure. Bands, not every transmission uses bands, but that right there is a band, or called a brake band. When it applies, it stops that drum from rotating. Clutches, clutch sets. There's lots of clutches in a transmission. Friction, steel, friction, steel, friction, steel. They engage and engage the clutch. A gear train of the transmission is the gear set. Let's see. Right here, it's kind of hard to see in these pictures, but right here there's a sun gear and a planetary gear. I'm going to explain all this stuff later, but this is just a quick overview. The shafts, right here on this transmission is the input shaft, and right here is the output shaft on this transmission. Valve body. Right here on this transmission is the valve body. Sprague clutches. Sprague clutch is a one-way clutch. So this transmission actually uses one here, I believe, and also one right here. And then you have your electronic components. So you have some solenoids, you have a wire harness right here with another solenoid. So that just gives you guys an idea. If you ever wanted to look inside a transmission, there you go. Now you kind of have an idea what it looks like inside. So we're just going to buzz through these components real quick. Again, some of you guys are never going to open up a transmission, some of you might, but it never hurts to just have an idea what is going on inside of a transmission, what makes your vehicle move down the road. That's why we're here, right? So this is the pump that we talked about. This is kind of the heart of the transmission. It supplies pressure and it supplies lube throughout the transmission. And again, remember I said this thing works on hydraulic operation, hydraulic pressure. Now it all sprouts from this pump right here. We're talking about bands. So again, not all transmission use bands, also known as brake bands, because they stop. What they do is when they apply, they stop a rotating drum. They are applied by a servo, which is right here. And then I also have in there, bands can break or wear out. So whenever I have a transmission open, I replace bands no matter what, because sometimes they crack. We see them crack here, we see them crack here, or they just plain wear out. It wears the lining away till there's nothing left. So you might run into that. Clutches apply using a piston and hydraulic pressure. So if you can imagine a piston in here, which strokes when hydraulic pressure comes through some tiny little bleed holes right here, applies a piston, and the piston squeezes these clutches, which fit inside this drum, squeezes them together. Frictions right here are made of a paper element, so it's a stamped steel round ring there with paper element glued onto it. Friction clutches need to be submerged in fluid or they will instantly burn up. And also friction discs are always next to a steel. So it always goes friction, steel, friction, steel. They always sit next to a steel. Okay, gear train of a transmission. A transmission uses gear sets to reduce or multiply rotating speeds. These gear sets are referred to as planetary gears. That's what they're called. The center gear is called the sun gear. You can see that in this diagram right here. And the outer gear is called the ring gear. And these little gears are referred to as planets. So it's referred to as a planetary gear set, but again, it changes the speed of if you have a shaft that splines into here, and you have a shaft that splines into, well, let's see here, splines into the end of here. So you can imagine it changes how, on this one, I believe we are reducing the speed. So one shaft spinning, the other shaft coming out is spinning at a much slower speed. So torque multiplication is what that's called. Our shafts, input and output shaft. So now on this particular transmission, the input shaft is part of the input drum. You can see that. So again, this right here is going to be what sticks into the torque converter. The output shaft comes out of the transmission and attaches directly to the rear drive shaft or transfer case. So engine RPM here, output RPM here. And it's the link between this and this that changes the speeds of the shafts. That really makes the transmission, that's what your transmission's function is. So moving on to valve body, that's a goofy looking thing. Valve body, what is a valve body? What does it do? Valve body actually routes fluid to apply the clutches or bands. So this thing commands the hydraulic fluid and routes it to different areas of the transmission. It does so using solenoids, which we have here, here, and here, springs, and check balls. It also controls pressures, and it's usually located on the bottom of the transmission or inside the transmission pan. Not always, but typically. Sprague clutches. Those are the one-way clutches I was telling you about. So on this one, this inner ring here is going to rotate clockwise, and it will not, no matter how hard you try, it will not rotate counterclockwise. It's a one-way clutch, a one-way directional clutch. Our electrical components, you can see a wire harness here. That's our internal wire harness, so that's submerged in fluid. Our solenoids, we have our shift solenoids right here. Our pressure manifold, that's this little guy right here. That actually has little almost buttons on the bottom side of it that when a hydraulic passage gets full of fluid and pressure, it's basically just a button that gets depressed, and it closes a switch, tells the transmission that cavity is full of pressure, basically tells the transmission what gear it's in. Speed sensors right here. And all this stuff is controlled by the transmission control module, or in some cases the PCM or powertrain control module. Some more transmission issue info for you here. Heat and water are some of the leading causes of transmission failures. So most of the time when a transmission fails, it's due to one of these two things. Heat. The magic number I have on here is 200 degrees. We like transmissions to stay under that. When a transmission, can't talk today. When a transmission overheats, it starts burning up clutches, it starts warping parts, and bad things happen. Water. Transmissions hate water. Just like cats, transmissions hate water. A little bit of a water can ruin a transmission. And so you're thinking, how does water get inside a transmission? Well, a faulty transmission cooler or radiator or heat exchanger can cause fluid contamination. There's always going to be some type of system on there where the transmission fluid goes right up against the transmission fluid goes right up against the engine coolant using some sort of a heat exchanger. Unless somebody like us has installed an aftermarket cooler, which then you route the transmission cooler lines to a large cooler up front, and it goes right back to the transmission. It does not go through the radiator. So sometimes if we have a burst radiator or a radiator that's mixing fluids, you either have to replace the radiator or install that cooler that I just talked about, aftermarket cooler. Also, running a transmission too low on fluid will burn it up. It'll burn up clutches and it'll cause your transmission to fail. There's something called a clutch band application chart that you'll be able to look up through your shop's information system that can help diagnose transmission failures. So say you have a transmission that comes in and it's missing third gear. You can look at that apply chart and say, oh, it looks like right here it says direct clutches are applied in third gear. So I bet you would have a problem with the direct clutches inside the transmission. Another thing is, so whenever you get a transmission issue in, we always like to do the following. So say a customer brings a transmission in and he says the transmission feels like it only has first and third gear. Well, we want to go in there, and I always like to grab the scanner and drive it and see if the transmission is doing what it's being told or if it is doing its own thing. So I like to watch what's called gear command on the scanner. You go drive the vehicle, I see first gear is commanded, now I see second gear is commanded. We don't have second gear in the trans. All of a sudden third gear is commanded and it engages third gear, and then finally fourth gear is commanded. Nothing happens again in the transmission. So we pretty much just, that points us in one direction or another. We pretty much just said, okay, the computer's telling it to shift, the transmission is not. So we just narrowed it down to a transmission problem rather than a control problem. On the other hand, you go drive a vehicle and it only has third gear. You throw the scanner on it, you go to gear command, guess what? The computer is telling it to be in third gear. So the transmission's doing exactly what it's being told. It's not being told to shift gears. It's being told to stay in third gear. So sometimes transmissions are stuck in third gear. If a certain code's being set, we call that limp mode. It goes into like a limp home mode. But anyway, okay, moving on. I could talk all day about that. Transmission fluid and filters. Transmission fluid is a type of oil that's really low foaming fluid, and it also has detergents. Transmissions are typically stay really clean inside because this fluid has a lot of detergents in it. Some different types of transmission fluid are Dexron, Dex 3, Dex 6, Mercon, which is Ford. There's a lot of different ones. So most applications can use a multi-vehicle synthetic. This is what I do in my shop. I buy at bulk and I have a barrel of multi-vehicle synthetic fluid, and I can put that in 80% of the transmissions that come in the door. But there are certain transmissions that we have to use specific fluid on, or factory fluid. Volkswagen, Audi. I use it on Hondas and also brand new vehicles. Newer Fords have a special transmission fluid that I don't believe is qualified yet in my universal fluid or multi-vehicle fluid. So, and then on brand new vehicles, sometimes you look at your whatever fluid you're using and it doesn't have the qualifications. Doesn't mean it wouldn't work, but sometimes you just want to err on the safe side and like, I don't know, this is a brand new vehicle, I'm just going to put factory fluid in it, that way we know we're safe. But yeah, Volkswagens and Audis, they use a special type called Esso oil. It's a brown in color and it's almost like a gear lube. It's really goofy stuff and it's really expensive. It's like 25 bucks a quart, so pretty stupid. Most transmissions have filters inside of the transmission pan that is replaceable. Some transmissions also have a spin-on filter in addition to the pickup filter. Spin-on filter either external, or there's even one transmission that has an internal spin-on filter. So you drop the pan and you have a filter that looks like that, and you also have a filter, a spin-on filter, which looks just like an oil filter, engine oil filter. A tech tip for you guys, always check for a tight fit on the O-ring where the filter attaches. So on this one, right here is where your filter actually attaches into the transmission. It actually fits into the transmission pump. So on this particular transmission, there's a rubber O-ring that stays in the pump. But anyway, when I'm putting that filter up, I want to check for a tight fit. If I put it in and it wants to fall right out, that's not a good seal. Sometimes even the seals, you pull the transmission filter out and it's going to stick right here, and then guess what? You try to put a new filter in, there's nothing there. But if you have a loose fitting seal, a loose fitting seal, you always want to address that, because if we have a loose seal right here, the transmission fluid is down here rather than it sucking fluid through the filter and back up through the seal. We could suck air through there, and we don't want to do that. Always match up filters. So when you're replacing a filter, match it up with the old one to make sure you got the correct one. Make sure you don't put something that's incorrect in there. There's even some transmissions use different filters for two-wheel drive versus four-wheel drive applications. So just always match them up. A tech tip, you can split open a filter to look for debris. Sometimes we have a transmission that's acting up and we drop the pan to inspect to look for any debris. And then sometimes it's also a good idea to crack open the filter, open it up, and then you can see what the filter's been catching. Sometimes you find a lot of clutch or metal in there, and that gives you an idea, what's happening inside that transmission, if you got problems or not. Okay, so we are switching gears literally here. We're going to talk about manual transmissions. So manual transmission, or most of them are 5-speed transmissions. Manual transmissions use a clutch instead of a torque converter. So no more torque converter. Instead, the driver's doing all the work. They use a clutch to engage or disengage power to the engine. Manual transmission uses shift forks to move slider gears to engaged fixed gears. This gear right here, that's a slider gear. So as you move your shift lever, it's going to slide this gear up here to engage the next gear right here. They also use what's called a synchro to match the gear speed to allow a smooth transition. This yellow colored thing right here, that's a synchro. And how that works, if you would look at a synchro, it's got a tapered fitting. So as this gear slides in, it hits that synchro, the harder it pushes, the tighter that taper gets, and it actually makes the shaft and the gear, it allows them to spin at the same speed, and then the gear pops in. So it slows down, say it slows down this gear to allow it to pop into there. When you have worn out synchros, that's when you start getting grinding shifts. You go to make a shift and it grinds into gear. That's usually a sign of a worn out synchro. Manual transmissions will either take a gear lube, or even some take automatic transmission fluid in their manual transmissions. Kind of a rule of thumb for this is if you have an aluminum cased transmission, it's going to take ATF for automatic trans fluid. If you have a cast iron case, it's typically going to take gear lube. So let's talk about the clutch. The clutch allows the engine to be disengaged from the transmission. Typical lifespan of a clutch is around 100,000 miles. So right here is a picture of a clutch. And this right here is the friction disc. This is attached to the engine. So there's your flywheel. And right here is what's called a pressure plate. So we'll hop right over here. Here's our throwout fork. So when you apply the clutch, a rod's going to press on this, which in turn presses on this throwout bearing. That's going to press on the inner diameter right here, or on this picture, it's going to be right here. By pressing on those little fingers, it actually pries the pressure plate away from the flywheel, allowing the friction disc to rotate freely. As you let your foot off the clutch, the two pieces close together, put pressure on the friction, and away you go. I'm going to show you guys the hydraulic portion of that. So most clutches use hydraulic pressure, some use a cable, most use this hydraulic pressure to engage and disengage clutches. So right here, if you can imagine, that's your clutch pedal. As you push on that, the clutch pedal linkage goes into the master cylinder. That's going to be located on the firewall inside the hood. Your master cylinder has a line that runs to the slave cylinder. So what you're doing basically is you're moving a piston in here. The piston pushes fluid and moves another piston in here. So in turn, you're just transferring energy from here to right here to move the lever, disengage the clutch. Okay, transfer case or T-case allows for four-wheel drive or all-wheel drive operation. Some transfer cases also have a low range for additional gear reduction. Pickups sometimes they'll have what's 2 high, 4 high, and 4 low. And 4 low is really, that's like a creeper gear. You probably can't go over 40 miles an hour in 4 low. But that's used for, pulling a stump out of the ground, or I don't really ever use it, but some people do. Rule of thumb, cast iron transfer cases take gear lube, and aluminum T cases take trans fluid again, or GM has a special fluid called Auto Track. It's blue for their auto T cases, which have clutches in them. Transfer cases can either be electronically or can either be manually or electronically shifted. So some of the transmissions, especially in like work trucks, that type of thing, have a lever. You actually grab it, pull it back into four-wheel drive. Some have a button, push button engagement. Drive shafts. Drive shafts is what the piece that transfers the power to the axles. CV axles are used for transaxle units. So this is going to be a rear-wheel drive application. This is going to be a front-wheel drive application. Universal joint, or a U-joint, allows the drive shaft to move at different angles. So right here, you have a U-joint. That's what it looks like removed. And again, CV axles. So that thing can be, at different angles. It can be bent. It just allows power to get transferred through the shaft at different angles. So the rear axle. There's two different types of rear axles, a straight axle or an independent rear suspension, or an independent axle. Right here we have a straight axle. You'll see that on some pickups, that type of thing. Right here is an independent. So you can see how they called it independent, because the wheels can move independently of one another. The rear differential. The rear diff uses a ring and pinion gears to transfer power to the rear wheels. So you're taking power coming in this direction, and ring and pinion takes the power, splits it, and puts it to the wheels, excuse me. An open rear end uses spider gears, which an open rear end is, there's nothing locking the two wheels together. So you can spin one wheel independently of the other wheel. An example of this is, here in Michigan where we get snow, you can get stuck. Say you're stuck in your driveway, you step on the throttle, one tire spins, you look at the other tire, it's not spinning at all. So a locking rear differential or limited slip uses clutches or gears to provide better traction. So in a locking rear differential, you're stuck in the driveway, you step on the throttle, it's going to spin both wheels as opposed to just one. So they both work. Some vehicles you can either get, some vehicles it's an option to get a limited slip or locking rear differential. So it's hard to tell until you open it up. Sometimes you won't even be able to tell which one it's got. but those are the differences. Okay, so that is it. That was easy. Hit your easy button. So get ready for our next module, which is Module 7. Module 7, we're going to talk all about suspension. Steering, suspension, and brakes. So come on back and we will see you then.